Hello, Grace here with some bug facts. Today we're breaking down one of the greatest innovations in animal history, insect flight. Insects were the first creatures on Earth to fly long before birds, bats, or pterosaurs. We're talking over 300 million years of aerial evolution, and the results are pretty wild. The jury is still out on if insect wings evolved from gill like structures on ancient aquatic nymphs or if they were extensions of the thorax used for gliding. Either way, these early flaps eventually became fully articulated wings that we see today. And insect wings work completely different from bird wings. They're not powered by muscles inside the wing. Instead, they are actually controlled by indirect flight muscles inside the thorax. When the thorax flexes, the wings flap. It'd be almost like a human trying to fly by wiggling our rib cage. And the wing beats, they're fast. Some flies can beat their wings hundreds of times per second, way too fast for muscles to contract individually. Instead, insects are using something called asynchronous flight muscles, which contract rhythmically on their own once activated, sort of like a biological vibration engine. Dragonflies and damselflies are the one exception. They have direct flight muscles, meaning each wing is controlled individually. That's why they can hover, go backwards, go sideways, and pivot just like tiny helicopters. But how do insects actually stay in the air? They use a combination of clever aerodynamics. They have leading edge vortices, which are tiny whirlwinds that stick to the wing and help create extra lift. They also use the clap and fling, where the wings touch at the top of the stroke and fling apart, boosting lift. And they also can use figure eight wing beats, generating both lift and thrust in a single motion. These tricks let insects fly at slow speeds, hover, and make sharp turns that would stall a bird or an airplane instantly. And maneuverability, these guys can change directions in milliseconds by adjusting wing angle, stroke amplitude, and even the timing between left and right wings. That's why houseflies are so hard to swat. They see your hand coming and reroute their flight path before you get anywhere close. So, next time you see a bee hovering, a dragonfly darting, or a fly, remember you're watching the result of hundreds of millions of years of engineering and little tiny flying machines perfected. Stay curious and keep exploring the tiny world around you.